Assalamualaikum warahmatullahi wabarakatuh. To our lecturer, that is Dr. Zahasra binti Abu Talib. My name is Muhammad Arif bin Zulkifli and my metric number is CF2085. We are from Group 2 and we will present about our project in Foundation Engineering. This is our group members in our company's organization chart, and the project director of the project is Megat Nu'man bin Azmi. Our group will present the structural plan and the location we have chosen to analyze the soil profile, the design foundation, and soil improvement in construction. And our company name is Geosoil Engineering Service Sendirian Berhad. Geosoil Engineering Service Sendirian Berhad possess most of the essential machineries and equipment to conduct subsurface exploration for foundation design, slope stability, and studies, and other engineering requirements. As a result, Geosoil Engineering Service Sendirian Berhad is capable of performing the following service utilizing boring rigs on land and over water or offshore. Our areas of competence include the design and administration of construction projects in addition to architecture and infrastructural building service. With our considerable background in a wide range of projects, we place a premium on customer satisfaction and make it a point to maintain open and responsiveness of contact. Our commitment to quality helps to overcome the problems, satisfy the project needs, and minimize the construction delays. We will make it a priority to work closely with our customer in order to accomplish the objective of the building project in quickly.
Next, I will continue about project backgrounds. My name is Muhammad Hafiz bin Johan, and this project was located at Kawasan Bandar Al-Muktafi Bilasha, Pakar, Terengganu. During the soil investigation, there are two tests were conducted to understand the soil. First, standard penetration test or SPT. A test was done to measure the soil strength at different depth. A special tool was used to collect soil samples, and the resistance was recorded by counting the number of blows needed. And second test is disturbed and undisturbed soil samples. Soil samples were taken to study its properties, and some samples were disturbed during collection while others were kept intact. In the laboratory, two tests were performed. First, direct shear test and Atterberg limit test.
Okay, next is project structure. The work on the school building soil research at Pakar, Terengganu is covered in this section. The purpose of this research is to collect geotechnical engineering data regarding the ground under the site, which will be utilized to guide the design and assessment of the proposed structural foundation. At the site, 4 boreholes and 4 Macintosh probes tests were performed. The deep borehole was progressed using the rotary boring machine. Figure 3.1 is the planned school foundation. This is the load used for each column. So as we can see, this is all the column and then with their own load. Okay, then we categorize with 3 groups, which is group A, the load is from 0 to 500, B is 500 to 1000 kilonewton, and then the last one is group C is 1000 to 1500. Next, I will explain a little bit about bore log. So a bore log is a record documenting the conditions and characteristic of geotechnical exploratory activities such as mining and drilling borehole. Visual inspection and geotechnical logging equipment are utilized to collect samples and obtain data along the drill axis. The data is recorded using a regular log spreadsheet and includes details such as project name, location, drill rig type, boring depth, drilling technique, sample recovery, soil classification, consistency, color, grain size, particle shape, sedimentary structure, blow count, layer, boundaries and thickness, plasticity, topsoil thickness, mineral composition, texture and strength. soil profile. The soil profile is the vertical portion of the soil that displays all of its layers. From the soil's surface, the soil profile reaches the parent rock material. It allows for the examination of soil properties and structures identified by laboratory tests. For the soil profile of this project, we used result from borehole tree. And then this is the summary of the soil profile of our project. So as we can see, this is the every layer of type of soil. So for the layer 1, we can see the topsoil is brown and sandy silt. Then the layer 2 is loose, light grey, fine to coarse sand. Same goes with layer 3. And then the layer 4 is medium stiff, light grey, sandy silt with high plasticity. And then we go to the layer 5 is medium stiff to stiff, light grey, sandy silt with intermediate plasticity. And then the layer 6 is loose, light grey, clayey sand. The layer 7 is soft to medium stiff, brown to dark brown, clayey silt with traces of gravel. And then the layer 8 is medium stiff, brown to dark brown, clayey silt with traces of gravel. And then same goes with layer 9 is medium stiff, brown to dark brown, clayey silt with intermediate plasticity. And then layer 11 is loose. Layer 10 is loose, dark brown, silty sand. And then the layer 11 same with layer 10. And then we can see the layer 12 to layer 14 is medium dense, light grey, silty sand. And then layer 15 to layer 17 is medium dense, light grey, gravelly sand. And then layer 18 is medium dense, light grey, silty sand. And then the layer 19 and layer 20 is fair, medium, strong rock, light grey, moderate to slightly weathered marble.
Assalamualaikum and good day to everyone. My name is Nurul Maizatun Najihah binti Basirun and my metric number is CF2068. In this chapter, I will explain about the deep foundation that have been selected in our project. Deep foundation refers to a type of structural support system used in construction to transfer load from a building or structure to deeper and more stable layer of soil or rock. Deep foundation is used in construction when the surface soil cannot support the load. They are designed to handle heavier load and minimize settlement issue. Next, in our project, we have opted to design the foundation using pile foundation. Pile foundation are a type of deep foundation that utilize long and slender structural element. Pile are installed into the ground through various methods such as driving, drilling or casting them in place. The primary purpose of pile foundation is to transfer the load from the structure to more competent soil or rock layer at greater depth. That's all from me. I will pass the next part in the designing the foundation to my teammates. Thank you.
Assalamualaikum and good days to Dr. Zahasra binti Abu Talib and my fellow friends. Today, I will explain the parts of pile foundation design. This is one example of the calculation for designing pile foundation design in this project. This part is the detailing for the pile foundation design. For the size for this pile is 400 mm times 400 mm. For design checking, we have three foundation that we choose, which is C26, C34 and C12. All of the proposed size for this pile is 400 mm times 400 mm. The value of the NED in kilonewton for three of this selected pile design is 418.50, 944 and 4, and 1316.30. For the conclusion, the settlement check for all the pile design is okay. Thank you.
Assalamualaikum and good day. My name is Muhammad Yuslam bin Muhammad Yusuf. I will present the last chapter of the project. So, for discussion part, in this project, we conducted a detailed calculation for the design of pipe foundation. We analyzed the loading from various columns using advanced software known as STEAM. By accurately assessing the loads, we were able to determine the necessary design requirements for the pipe foundation, ensuring its stability and structural integrity. The proposed column sizes for this project were 400 x 400 mm, and we took into account various parameters such as a load on the pipe from the column and soil, ultimate load on the pipe, and settlement. Settlement is a critical aspect of foundation design as it determines the stability and performance of the structure over time. I am pleased to inform that the settlement check yield positive results. The settlement value we obtained was 21.47 mm, which is well below the specific limit of 25 mm. This indicates that the pipe foundation meets the settlement requirements and ensures the stability and reliability of the structure. In summary, our project showcased the importance of deep foundation, particularly pipe footings, in ensuring the stability and durability of structures. Through meticulous calculation and design check, we have successfully determined the appropriate pipe size and reinforcement for the foundation, addressing the specific load requirement of each column. The settlement checks confirm that our design meets the necessary standards. Next, for conclusion, in summary, the report highlights the importance of thorough site investigation and soil testing for designing a strong foundation. This project focused on designing the foundation for a school building in Paka, Terengganu. The investigation involved analyzing soil properties to determine the appropriate foundation type. Factors like design customization, building capacity, settlement, and soil improvement measures were carefully considered. Field exploration and testing involved methods like standard penetration tests to assess soil carrying capacity. Disturbed and undisturbed soil samples were collected for comprehensive analysis, including shear strength and consistency tests. The project structure included borehole and test details, and the load applied to each column were categorized for design purposes. Overall, the project followed a meticulous approach to ensure the stable and durable foundation. The findings contribute to the knowledge of foundation engineering and serve as a valuable resource for future reference. That's all from us. Thank you for your attention, and I hope our presentation has provided valuable insights into the significance of deep foundation and their role in constructing stable and reliable structures. Bye!